All right, thank you so much. So yeah, my name is Perchyk Baudisch. I shouldn't be here. Dominik should be giving this talk. As you can see, he's the first author on this paper, and together with a group of students at Hasselplatten Institute. But since Dominik can't be here right now, I'll be giving this talk for him, showing off his great work. So, quick summary of the talk. I'm going to tell you more about interaction on touch floors. The key ideas are well, everyone in the field seems to understand that these are good for standing on them. Interact while standing. We propose letting people sit down, lie down, take on all these other postures for better ergonomics, less fatigue, as well as changing postures. And I'm going to tell you about a system that we wrote that allows people to change their pose and maintain their sessions, so you can take your documents with you as you go through these poses. All right, let me start at the beginning. Why floors in the first place? So we've been on this topic for a couple of years now. And the thing that gets us excited about is the fact that they scale. So when you think of tables, they're certainly of limited size. Many of the tables you see are kind of coffee table size. And the reason is, if you try to make them larger, you kind of could, but users would have difficulties reaching the contents that's further out. So as a consequence, you see things that are between coffee table size and a little bit larger than that. I think display walls are a good step in the right direction. You can make them arbitrary size in one dimension, so you could have a very long wall to show more information. But if you really wanted to make something really large, say we wanted the Chi interactivity program on one big interactive surface, that would not be a wall. That would have to be a floor, because the floor is the only form factor that scales in 2 dimensions, so you could conceptually make them hundreds of square meters. People have actually made installations that were over 100 square meters large. If you're less interested in many users at the same time, you can also think of them as the only tool for visualizing very large amounts of data for a single individual to explore by walking through the data. So that's why we're excited about this. We started this project 5 years ago, and let me just give you a quick overview here. So at WIS 2010, we first proposed the idea of high-resolution touch sensing for floors, and we used that to recognize users based on their shoe prints. So this is the first multi-toe prototype. You can actually see it was oh, okay. Well, the gamma correction prevents you from seeing very much here. Very small prototype. Here's some basic interaction. Users could select different primitives on it. And oh my God, that's very, very dark. Okay, what you would see is there's a shoe, there's a foot tapping around, drawing something. Someone else walks through the image without interfering, because we distinguish people based on their shoe recognition. And then the first user continued to interact. Then the year after, we upgraded to a larger platform. We created a system for ourselves. We moved to a new building. So what you see here is we had a chance to get 2 rooms on top of each other and put a glass sheet in between. And that allowed us to create a floor that was 8 square meters large, 30 megapixels of sensing, camera below, projection below. And then we presented here at Chi the system called Gravity Space, and the idea of Gravity Space was to not just reconstruct feet, but do a 3D reconstruction. So we'd actually reconstruct the entire pose of the human body using inverse kinematics. So this is what the floor would see: shoe prints. If you would sit down, it would see other parts of your body. We would reconstruct as much as we ever possibly could of what was happening above the floor. And then we came back last year, and you see we're inching our way up in the food chain here. We started with the hardware, basic interaction. Then last year we actually finally looked at actually interacting with users. We created something called kickables, where we created physical objects that people could kick around and manipulate in various ways to interact with very basic elements of interaction, such as GUIs and so on. All right, so we probably spent more time on these things than other people, and as a consequence, we noticed what was broken about it, and what was broken about it was they were very tiring. So obviously, standing on these things over extended periods of time was unpleasant because of the legs, but the bigger issue was actually we found ourselves looking down the whole time, and that actually became some sort of an ergonomic problem over time. So as we were excited about lots of data, interacting, big problem solving, you don't solve these things in 10 minutes. We'd stand on these things over longer periods of time, and it was not a pleasant experience. So we felt like we had to revisit this topic, and that's what I want to talk about today. So our approach to this whole thing comes out of this simple observation. If you think of multi-display environments, for example, like systems that have a wall display and a table and something else, every component in there has its own affordance. So the wall wants you to stand, and the table wants you to sit, and so on. And if you look at the floor, actually, it supports many of these things at the same time. You could sit on it, you could stand on it, you can lie on it, and that's exactly what we're exploiting in this work here. So there's 3 key ideas. Number 1, let people not just stand, let them interact in all types of other poses, because other poses may actually be more ergonomic, and I'll test that in a second. Number two, any pose will eventually get tiring, so if you want to interact over very extended periods of time, we often change our pose. The same if we do a tax return or something, we actually like go to the sofa and kind of do different poses. And then number three, if people actually change poses, we might need to support them by letting them switch between these poses and help them take their data with them as they do so. And there's a little bit of a preview of one facet of the system here. So that aspect, what we have to do is we have to kind of analyze the area in these different poses. For example, for standing, you might have your document spread out over the whole surface. You might take on a different pose. Here I'm showing you one lying on your belly. You might have a different area you can access, and we somehow have to figure out how we can make your data transition between these different things. So I'm going to show you in reverse what I'm going to show in the rest of this talk. At the very end, I'm going to show you the system we build. I'm going to show you some of the interactive features in there. Before we could do that, we first had to do some analysis. How does this work? What are the main parameters? You know, what areas can people see and touch and so on. But the very first thing we did is we verified if the idea is a good one in the first place, and that meant, well, the main idea was that other poses are actually more ergonomic than standing, so let's quickly check if that's the case. So let me start with the first one, verify that there is interesting poses. We wrote this super simple application. It's a whack-a-mole game, so what people do here is buttons pop up, and then the user taps on it. So green button, user has to tap on it, and we just did 60 seconds, super short actually, but we did this across lots of different poses, so they would lie down and sit on different types of chairs. We tried on a lot of things, and the green ones actually turn out to be more rated as being more ergonomic than standing, so people prefer sitting on a chair in a lotus position and certain types of lying. So so here's how people rate this, and let me just focus your attention on the first one, which is interesting. So we asked people twice, how fatiguing is this? And it turns out if you just place people on the floor, in the beginning they say the white bar, this is not tiresome at all. But if you just have them 1 minute, which is not a representation of a real session, after 1 minute already they will say that this is tiring because they find themselves standing one foot and tapping with the other, which is a very tiring interactivity. And it turns out these other positions like sitting and different types of lying down and so actually are rated as less tiring. Now the next question was, you know, well, is there one favorite pose? Is it sufficient? Is there one pose everyone likes? Then we would support only that and we'd be done. And the answer is no. We asked people, what is your favorite pose? There it is. Everyone shows, there's one that was not chosen. Every other pose had at least one fan among the reasonably small number of participants. So the first study suggested to us that if we implemented some sort of a view manager for a floor, we would have to cover a good number of positions. In this case, we chose to do all of them. Number two, we wanted to start determining the parameters. You know, what can people see, what can they interact with? So we still piggyback that onto the first study, the whack-a-mole game. And what we did is we asked people to scale the play field here before they interacted with it and place it in a way that would work for them. And what you see here is, this is a pretty obvious insight. I'd say the white bars show you how big they made the interface. And when they stood, they actually used 10 by 10 centimeter buttons, and that would scale further down with the bars as they start lying down. And the dashed line actually shows you what we would have guessed just extrapolating based from the distance between the head and the floor. And so what you see is this correlates reasonably well. The simple insight is if users interact close to the floor, then obviously contents can be scaled down. There's one second factor, which is as they get really close to the ground, they start using their hands again. So in some ways, even though it's a floor, it becomes a touch, a finger touch thing again, and then contents can shrink a little further. All right, next step, we had to look at placing contents. And for that purpose, we're building on a range of work that published at CHI and related conferences, including supple display bubbles and occlusion-aware interfaces. And let me just show you the quick result of this. For every pose, we try to determine what's a good space for placing our interfaces so that the users could see them and touch them, because that would be necessary for the interaction. So for example, you see here, as you're lying on your belly, you actually get, you have a reasonable, it kind of extended as long as your arms are in front of you. If you're standing, things look different. So here's how we figured this one out. We wrote a little simulation here. This is one of the team members, Mariya. She's wearing a motion capture suit. And everything that's, everything that's red is where she's looking at right now. The middle red stuff is her peripheral vision and things she can easily look at by just turning her head, and then everything behind her is contents that's really inaccessible. So here's kind of the summary of this. The little cone that's dashed, again, let me point out just the position lying on your belly, has a reasonably small area that you can really access. The reason is that it's very difficult to turn your head in this position. Certainly everything that's occluded by your body is completely inaccessible. At the same time, material behind you is essentially inaccessible as well. You would have to get up and go kind of move around. So you would want to place contents just in front of the user. In contrast, we treated standing as a somewhat specialized position because even though arguably the stuff under your feet you cannot see and access, you can so easily walk around that we thought this was okay. Second part is what can users touch. Again, we made a very simple app. We let people just paint into the areas that they can access, and here's again the overview. So here's what you see for lying down on your belly, for example. You get the classic snow angel. If you've ever been on a ski vacation and lied, you or your kids or did this, that's what you get. And then again, the standing position is a little different, and everything else is in between. So what we did now is we intersected these two things, and this intersection told us this is the space that users can see and touch, and this would be a good position to place our contents in. And again, you get like this kind of snow angel thing for the lying down. Essentially the entire floor for standing up, not because everything is accessible, but because it's possible to walk around easily. And then the poses in between are correspondingly different. So for example, if you sit on a chair, you may access in front of you using your feet. All right, so the good news we got out of this was it actually worked out reasonably well, because those things where you were higher up and away from the floor required larger objects, but you were also more mobile, so you could access larger areas, and the closer you got to the ground, we could scale contents down, but that's also what we needed to do because you could access less content. So the fact, further away, larger objects, close to the floor, smaller object actually worked out, because ultimately they all give you access to somewhat reasonably similar amount of information. All right, so based on this, we could kind of put a system together called Pose UI, and we used the hardware I showed you earlier, the 8 square meter touch floor, and we helped ourselves a little bit with the motion capture system to be able to explore a little bit more of the posture of the user. And then we made a couple of mistakes. The first versions we made, we tried to optimize the layout. So this is just one of many versions we did, where we tried to interactively select which objects we would take with ourselves. So for example, here Marsha's sitting down, and just the objects that are close to her were taken away with it. We did some versions where we tried to relay out things, optimize things, squeeze more into the available space, and all of this completely tanked. The reason why it tanked was because it was confusing for people. Then when they changed their position, they had no understanding anymore where the documents were, and they had difficulty continuing their session for that matter. And we wanted these pose changes to happen a lot, so it would be catastrophic somehow if you changed your pose and then afterwards you wouldn't know anymore where your stuff was. So the final version was then super, super simple, and let me just show you what this looks like. We were kind of almost disappointed by how simple it became. But it was the right thing to do. So what you see here is that contents is actually laid out on the backdrop, and we take the entire backdrop with us. So let me show this here. So even though there's no animation, you actually have a sense where he's coming from, because we introduced this background object, kind of this piece of hardwood floor, and rather than having the backdrop anchored with the floor, we anchored the backdrop with the documents. So there's kind of this view of a display window, if you will. And as you move around, the whole thing moves with you, and all the documents remain their position on this backdrop. And as a result, any of these transitions visually explain themselves very, very easily this way. We had to do a couple of tricks. So for example, sometimes there's clipping, because you reach the edge of the screen, and with physical objects as well. So we introduced this idea of kind of bending objects down there to kind of visualize what happened in these locations. Here's how we deal with occlusion. You might recognize these little elements here from the gravity space paper. On these things, actually, documents get pulled aside pretty dramatically. We decided to do a real cut here in between. Rather than just pushing documents in all directions, we kind of surgically cut the thing open, and that allowed us to maintain more of the object interrelations. So everything along the edge is still aligned, and everything across is just separated by the simple cut. Here's another perspective of one of these cubes here. In the default case, we just assume that you're walking for the purpose of accessing other documents, right? So if the thing followed you the whole time, you would never be able to access anything but the things in front of you. And so we actually require an active mode change if you want to take your session with you, and then all the documents will follow. We allow users to use this borrowed space, so the space outside of that floor is something that you can use. We encourage it for temporary use, so you could actually place some documents there. But then if you return to another pose, these would be pushed off the floor, and so we recommend then that you clean up before this. And one way of doing this, for example, is by just using the floor itself to scoop up the documents that are outside the space. So finally, the little system supports multiple users. So Julian and Johannes may actually collaborate. They could work on these things as we're familiar with on multi-touch floor, but they can also decide just to have separate sessions for a moment, collaborate. Now the flow was just cloned. They can work independent from each other. And then when they're done with this part of the session, the floor reunites, and that allows you to use a large surface temporarily with multiple users. So that's what I want to say. To conclude, let me just remind you of the three ideas here. The first one is, it's commonly assumed that floors are for standing up interaction. We think that's not necessarily the case. I think they're very good for sitting down and all these other poses. I think they could actually, if you think of this as something in a smart home, something that fills your entire apartment, or something where you collaborate with many people in a large session, you know, paper making at Kai, whatever it is, allowing post changes is an interesting idea. And then it actually makes some sense to support these transitions using a view manager that allows you to take your documents along. Thank you so much, and I'll be happy to take your questions.
Hello. We are running like surprisingly on time, so we have time for quite a few questions. Maybe I would like to start myself. So when I was reading your paper, I was actually at home, like laying actually on the floor, leaning against the sofa, and I could totally see me like interacting on the floor, maybe to like buy some tickets to go to the cinema with the girls, or just controlling something in the house. So I totally see this kind of interaction being applied to like domestic environments and all that. The thing is that also the kind of interaction is also, we were talking with Georg about this kind of displays, floor displays being in a crossroad. You don't see yourself laying on a crossroad. Mm-hmm. So I wanted to ask you, as you might have been thinking about this for longer time than me, which kind of environments do you see these interactions taking place?
So the question is, what scenarios would be most appropriate? So in the debate, I think in the team we went back and forth. I think some of us talked about use in the home. You know, if you kind of a you become scenario where a future home, just the whole thing would be, you live in a cave essentially, right? I mean, you know, all the walls and everything is display as well as touch sensitive. And then obviously it makes perfect sense to lie around. I don't know, maybe at the Kai conference I can see us actually not just standing but also sitting. But I think obviously for like more frequented scenarios, you would, you would typically for hygienic reasons, you would prefer standing up, right? I think the largest installation I've seen was Epidemic by a French artist, and they did it at a kind of a trade show. They enabled a room a little bit larger than this one that we're in right now. This is quite substantial actually for that purpose. I think there's another question.
Yeah, I have a quick question. Ronald Wang from Samsung Research. Very interesting work. What I wonder is that having the projections from underneath actually is a little bit hard to install, especially in a home environment. So I wonder, have you ever considered other like installment, like top-down or some other ways?
Absolutely. So it's an absolute perfect understanding. The floor is a placeholder technology, right? It's a very elaborate placeholder. I think in the future, it's not just going to be top projection. I think we're going to see both the sensor and the display being integrated in a carpet-like form factor. What you would expect is that you would have, so there's a couple of prototypes where people wove LEDs into these things. You could envision that the resolution of that goes up to the resolution of LED walls. And then there's work, there's several startups actually by Ken Perlin and associates. Initially there was the Unmouse Pad. They have new versions of that. And I think the combination of these two is ultimately what's going to go. I think the vision is that when we're all a little bit older, you're moving into an apartment, someone's just going to roll out a carpet that does exactly this and plug it in, and that will be the sensing for the home then.
That's cool. Thank you.
You're welcome.
There's time for one more very quick question.
Hi, this is Asako Kimura from Risch University, and I have I wondered that when we come closer to the floor. For example, because your system makes smaller when you close to the floor, but at that time the document could be smaller, then it will be a little bit unreadable. So how do you think about that?
Absolutely. So I was trying to allude to this in an earlier slide. Let me bring this up again. So this is exactly what we bumped into. So there's two reasons why you change pose. Number two is the one I talked about most, because that's the one that we're proposing. It's the idea of you'd want to change your pose, but you actually would like to everything to stay the same. And then the more common one is actually you want to explore. So you want to see different documents, or maybe you're kneeling down to see something in a lot of detail. So we ended up, in this case, having an explicit mode change. In some cases, we used a clicker for that purpose. So you actually say, you know, if you push, that means the system's going to follow you. You can drag your session around with you. If you don't, then actually things will stay the same. You can actually kneel down and, like, you know, piece out individual pixels. But it's a very astute observation, absolutely.
Thank you.
Right. Then thank you so much.
Thanks a lot, Patrick.